Going with your.
Yeah, that was great. That sounds great. That was the first I have. My introducing myself was top of the list. My name's Christian Sarason. I work at the Applied Washington. I went to grad school at the university. I graduated in '98 with a master's, and did a bunch of things in between. So, teaching and writing software for a living, and now I'm doing research. So I sort of came full circle back to the University of Washington after being in a bunch of different places. Throughout my career, I've really been sort of a data munging. I mean, I was kind of doing data science before data science was cool, insofar as I was manipulating data into a form that it could be used for analysis or integration into numerical models. So that's really the core of the work that I'm doing now as well. I first was introduced to OceanHackWeek in 2018 after having not written code for about 10 years. I came back and started. It was great to get reintroduced because everything has changed and all the tools are better and easier to use. To give a sort of overview of package management in Python, as well as just things to think about beyond Python. A lot of the concepts are the same, and how things have changed over time. So with that, let me share my screen. Stand by. Oh wait, sorry, wrong thing. It's way easier. Now you can just see my whole screen, and hopefully my email notifications don't pop up. But all right, so let's get started. I have made a test directory. This is where I was making my doing the work to prepare this presentation. But I'm going to go up one directory and sort of give you a quick tour. How many people, I can sort of see most of the faces and hands in there. How many of y'all have successfully fired up the JupyterHub and know something about Jupyter? Okay, so it looks like a lot of people know about JupyterHub and Jupyter. That's great. Jupyter in particular and JupyterHub are both really great ways to make sure that when you're working together, you're all working on the same page, and it's not, you don't spend all your time trying to install stuff that doesn't work. A lot of times, especially in hackathons, you could waste a lot of time trying to get some stupid package to work properly. So we don't have that problem here, which is great. You can find my, I think they're not in, yeah, I haven't updated my thing, but if you go in the OceanHackWeek tutorials and they're Monday, you'll see these notebooks, and I'll make sure to, that stuff got pushed out to the JupyterHub. I don't see it in mine right now, but I'm not sure why that is.
Christian, really quick.
Yeah.
Can you double check that you're sharing the right screen?
Oh, yeah, it doesn't look like, oh, you know what? I'm not sharing the right screen. Why is that? Thank you.
Yeah, no, thank you.
We also haven't formally gone accessing the JupyterHub yet or pulling tutorials.
Okay, great.
That there's a link in the Slack channel to access it, and I've nudged folks to try and access it on their own, but not giving a tour through what we've got going on.
Okay. Well, that's okay, because a lot of what I'm going to do is to just show some of the features, and then I think it will make sense. I didn't really spend a bunch of time getting my Git stuff together to make sure my JupyterHub was all intact, so I don't want to do that in a live demo. But now you should be looking at a JupyterHub screen. Is that right? That's what it looks like. Thanks for pointing that out. So in my screen, there's this, everyone will have this OceanHackWeek tutorials, and then it's split out by day, and there's all kinds of good stuff in there. I have made a separate directory because part of what I'm going to show is how to do package management. And so I wanted a clean directory that wasn't in, that had all the files already. So I've just created that directory here, and we'll talk about that in a second. So one of the things that is pretty handy about JupyterHub in particular, or Jupyter Lab, is if you're running it on your own machine, it's not quite as helpful. But on the hub, it's very helpful to be able to open your own console and poke around. You can open a terminal, and I already have one open up here, but I'll just open another one by clicking on that box. And then I'm here in the directory, and this is just sort of standard Unix. It's just a Unix bash console. One of the things I'm going to talk about is the structure of the Unix naming conventions, because that's really what package management does, is it just kind of plays around with how all that stuff works. So understanding a little bit about where these things come from is helpful. So if we go to the top of the directory tree, this is called the root. You'll see a whole bunch of directories here. There's one called bin, there's one called lib, there's one called etc. This is sort of the standard Unix top-level directory structure. And if you look in the bin directory, there's a whole bunch of programs that you can run, right? So things like echo, which is, or make directory here, right? These are all things you use every day at the Unix console. If you go into the /user directory, you'll see, oh, there's another bin, right? And here we go, there's bin. Oh, there's a whole bunch of other programs we can use. Some of them are the same ones. Here's make directory again. And then if we go to local, so now we're in /user/local, and we look in the directory there. Oh, there's one. It's called Pixi. And there is one in this sbin directory too. Look at that. So there's sort of like a hierarchy of these, we call them the binary directories, or the bin directory, right? If you look at your path, which is, for those of you that aren't familiar, the path is the order of where the operating system is going to look to find something. So in this path, there's something called this .pixi ends default bin, and then there's /user local sbin, and then there's /user local bin, and then user sbin, user bin, sbin, and bin. So if I type which make directory, anyone have any thoughts about where this should show up? Is in the user bin, even though it lists, it exists in /bin, right? So there are two programs with the same name in different locations. And the way that Unix basically prevents you from running the wrong one is by managing your path. Okay, this is sort of like Unix primer. I assume folks might know what I'm talking about. Can I see a show of hands? Does this make sense? I don't want to be pedantic. I can move on, go a lot quicker. If you've never seen any of this stuff, it's okay. It doesn't really matter, other than to keep in your mind this idea that the operating system needs to know where to run the program you're running and where to look for stuff. If you don't tell it explicitly what program you want to run, it's going to run the first one it finds in your path. So that brings me, I wrote a whole bunch of stuff here, which I'm not going to read, but you can read if you're interested. That brings me to this graphic, which is very fun, which is from XKCD, which is why can't I figure out why my Python program won't run? Because there are lots of different packages that all use Python in all kinds of different places, and they all depend on each other, and it can often turn into sort of a tangled mess, which is what this graphic is showing. If you've ever run into a problem where you can't find something and it's not working properly, chances are it's some version of this graphic where something you've installed has monkeyed around with your path and you don't know where things are. So, what do we do to solve that problem? We have this thing called package manager. So there's many different package managers that's kind of shown in this graphic. And there's a bunch of different ones that are very useful for scientific programming. There's a great, in last year's OceanHackWeek, Felipe put together a great, presentation on it, and I don't want to just recreate the software survival guide. It's worth a watch if you haven't, if you have questions about how Conda works, or if you're using Conda. His presentation was fantastic. It like walks through all of the little tips and tricks to make it useful. Really what Conda does is it's the same as your application installer on, Mac, or now Windows kind of has application installers too, where it just manages the installation of all the programs and makes sure that there's not contention between different packages that cause problems. It's very helpful. Of course, you can always be better. And, scientific, I know you guys talked about reproducible science this morning. One of the keys of doing reproducible science is being able to make sure that whatever code you share can be run on someone else's machine. And for years, this has not been the case. It still is probably not great, I would say, in my experience. But what happens is you get it working in one system, and then you try to give it to a colleague, and then they spend, a week trying to configure their system in the same way that your system is configured so that they can run it. So this is why reproducibility is a huge issue. And one of the ways that you can get towards reproducibility, the first way is to manage your code with version control using Git or something similar. And the second way is to really manage it's just another version of version control for managing all of the programs that you need to do whatever analysis or modeling or whatever you're doing for your project. So, of course, there's now a new effort to sort of have a new package manager that maybe is better than all the others, and it's called Pixi, and we're using it this year on the JupyterHub, and I've just started using it as a result, and it has some great features. They have a really nice long blog post about this at this link, where there's all kinds of, they can say it way better than I could ever do. So if you're interested, I recommend you read that. When I Googled, let's see, I wanted a graphic for Python package management. I thought, oh, a picture's worth 1,000 words. So let's go see what I can find. And there's 8,000 of these, so probably 1 million of these things. There's 10 pages of Google results just for a graphic on Python package management. There's lots of long rants one way or another about one thing is better than the other, and blah 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 blah. So it's not to say that Pixi is the best way to go, but it is. I can see the potential of it very usefully, and so to sort of motivate that, I wanted to give you an example of something happened in my day job. So my day job is to manage data from, I work with a modeling team, and we have also field assets, gliders, and floats and other things that are put out in the ocean and send all their data back in a variety of different formats. So my job is to take all those different formats and turn them into something useful that we can all look at. So it's a lot of data munging, usually of somebody's cool, clever new data format, trying to get it into one data format that's consistent across all the platforms and can be used for the model. So I develop a lot of code to do that. And when I use that code, I'm mostly working on my own machine, but I also share it with colleagues. And I ran into this very same problem when we were trying to run a specific Python package called OpenDrift, which takes model output and creates, you can sort of track floats. It's a very cool piece of software. But the installation's a little persnickety, and so I was trying to get my colleague to figure out how to get it to run on his computer. It worked fine on my computer, but did not on his. I was using Mamba to manage my package management, and so he also was trying to do that, but he had previously installed Python using Homebrew, and so his system was kind of just different from the start than mine was. And it took us probably 4 days to figure out how to get his Mamba environment or Conda environment to work properly. So partly that might just be that I didn't really know what I was doing. That's probably 80% of the 4 days. But also there was a fundamental problem with the way he was running. He had his own environment that he had to set up. The way Conda works is you have to set up your own environment, and you can do that with a lock file, and it gets better, but it wasn't working in our case. Pixi is a little different. Pixi, instead of having a environment in which all the Python dependencies are installed, and then you can run Python in that environment to have everything work, Pixi controls those environments with files in your project directory. And I'm going to go through a live demo and sort of show what that means, show what the difference is. There's a lot of reasons why that might be good or bad, but I just find it interesting. And I think it probably would have saved us a lot of time, because I wouldn't have had to sort of troubleshoot with my colleague over Zoom on what was going on with his computer, because I could have just say, use Pixi and run this environment, and it would just work, which, it's all aspirational. Questions? Okay. I'm going to do a live demo, and then there's definitely going to be time where we need to, hold on one sec. All right, guess I'm not going to do that. All right, so here we are in my directory. I've made this directory called package management test. And in this directory, there are 2 notebooks. There's this Pixi package management, which is the basically the Jupyter notebook I was looking at before. And then there's this simple KML example. So this is a very basic Python program to do some stuff. It imports some packages. It creates a way to make a point buffer around a point, right? So remember, my main day job is to be plotting gliders and floats and all this stuff, mostly on a map. So I want an easy way to make a 1,000-kilometer range ring and put it into KML, because a lot of people use KML on my team. So this is the function, and it sets this up. So I'm going to try and run this in JupyterLab, and we'll see what happens. So if I hit shift return, oh, it doesn't work. Our fabulous JupyterHub does not have this KML package, probably because no one asked for it, called Simple KML. So Simple KML is it's like it sounds, it's a simple KML project. So normally in Conda, what I would do now is I would go back out to the terminal, and I would say Conda install Simple KML. But there is no Conda on the JupyterHub. There is only Pixi. to manage our dependencies, which is okay because I'm going to show you how to do it. So now, the first step in using Pixi is to, this is similar to doing, creating an environment with Conda and create. So you do Pixi init. Probably, again, I'm a newbie at this, so I'm probably getting some of this wrong. But if I do that, say, oh, it created some stuff. What did it create in this directory? Oh, it made this file here, Pixi2ml. Let's see what that looks like. Okay, this looks promising. I'm sure there's some flag where I could have added a description. I can just edit it and add a description if I want. This is the name of the directory I'm in. That makes sense. This platform is Linux 64. Okay, great. This is the first version. And then there's these tasks and dependencies. I don't know much about the tasks. I think during the Q&A, maybe Alex can chime in about that. That's actually kind of a cool feature of Pixi. But right now you can see there's no dependencies because all I did was I initialized this directory as in this directory, I'm going to be using Pixi and I want to manage my dependencies using Pixi. And right now I haven't said what those dependencies are, so it's empty. So then if I do Pixi add simple KML, it goes out and thinks for a while. It's thinking some more. This is also similar to using Conda, as it has to go out and find the package, and then it has to make sure that it fits with all the dependencies and pull back. This is taking longer than it did during my practice session.
It's seeing the wrong Pixi.toml and trying to solve for the entire hub.
Yeah, you're right. Thanks, Alex. I'm glad you pointed that out. So I'm going to stop this. This is looking in the wrong place. So what it was trying to do, it was trying to, it had the warning right here. I should have seen it right away. It's looking for a different configuration file than the one I created when I initialized in this directory. So if I do this, and simple manifest path equal. I think that'll work. Oh, that worked. Yay. So one of the reasons we ran into that is that the one of the things with the JupyterHub is that it's shared. So you want to make sure not to be installing a whole bunch of packages in somebody else's environment, and so the permissions prevented it from. This is still taking a little bit of time. So let me just walk through what's happening here. This is saying, hey Pixi, please run, add a dependency called simple KML, and then it wants to add it to this manifest path. It's an explicit path to use the file that's in this directory. And it's installing a whole bunch of stuff because simple KML requires other packages, and so it has to pull those packages in and also install those ones, which we'll see in a second when we look at the files. Oh man, this part's also taking long.
Might be that everyone's trying to.
All right, let's see if we can.
I'm just slowing things down a touch, but.
The classic. No, still not done. Okay. Oh, that one's also empty. All right, sorry, stand by. I'm gonna stop sharing my screen for a second. This is the peril of the live demo. I apologize.
Mine worked successfully using the exact thing that you had up there, so I think it will probably work.
Let's see. So all I had to do was unshare my screen and stop looking at it, and then watch pot never boils. Here we go. So here now there are two files, right? Before there was a Pixi toml file, and now there's something called the Pixi lock file. So let's look at the Pixi toml file first. Oh, here's a simple one dependency, just this one. So now let's look at the Pixi lock file. So this lock file basically is the file that says we're using this simple KML, and here's every package actually that's required. And here you can see there are a lot of them. There's a lot more than just, and it has for each of these files, it has the name, the version, the build, which type, the channel it came from, the hash, and other dependencies. So there's a whole bunch of this stuff there. So great. So now it should work, right? We'll go back here, go back up to the top, and let's see what happens now. Whoops, you know what? The reason it failed again. Kernel doesn't know that I've updated my Pixi environment, so I'm going to restart the kernel. And now let's try again and see what happens. Oh. Oh, I think I know what happened. Sorry. Oh, live demos are always rough. Whoops. Let's try copying this.
You try changing the kernel.
Oh, change up here?
Mm-hmm.
Ah, there we go. Thank you. Now try. I forgot this step to add the PyKernel. So we're gonna Pixi add IPyKernel. Don't forget the manifest path. So I believe that I did actually walk through this and saved all the output and said what to do. So I should be following along more carefully. All right, that one looks done, and now let's see what happens. Oops, now I need to restart. The joys of programming. Just keep trying, something will happen. It's thinking. You can tell by this little star means that Jupyter is trying to do what I asked it to do. Oh, now it didn't work. Why? Oh, wait, now it says pandas isn't installed. So part of the reason that I'm going through this incredibly painstaking live demo is that this is what you're going to run into whenever you're managing packages. So I wanted to demonstrate what that actually looks like. This is confusing, right? Because before it failed down here, where it was importing the simple KML. Now it's failing up at the top where pandas, it's failing on the pandas import. And, you know, pandas should just work, right? So if I go over here and say import pandas, oh, and that's
Yeah.
this is not working because this is a Pixi based Jupyter notebook. If I start a different notebook, that's the IPy kernel, that's using the JupyterHub. So what I've done by trying to install an extra dependency, now I'm required to use, but I also have to install all those dependencies. So we can do that by if I do this time I'll actually cut and paste, so it'll be slightly less painful. Oops, sorry. Now I'm going to install those extra dependencies specifically to this TOML file, and then hopefully it'll all work. So this really does demonstrate one of the challenges that you run into with any kind of package management, whether it is for Python packages or whether you're managing a Unix server using apt or yum is the sort of Red Hat equivalent for the Debian apt. Always the package management and version control ends up mattering in a way that is sometimes really hard to predict. So you just kind of have to keep slogging through it. And if you do, eventually it all makes sense. So here we go. Let's see what happened. It added these things to the manifest. It installed them. And now I'm going to go here. I'm going to restart the kernel. And this is the Pixi IPy kernel. Okay, great. And now if I go do this, it's thinking again. And one of the reasons this initial startup is pretty slow is I believe, Alex, you can correct me if I'm wrong here, I'm guessing that's because it didn't have those packages before, and when it first goes through, it kind of has to compile them.
We're also all using the hub at the same time right now.
Well, there's that. Okay. I got a different wording which says, be careful, I'm being lazy and using an old, out-of-date, deprecated way to do stuff, but I'm not going to worry about it because it worked. And I'm going to do that. And then I'm going to do that. And then eventually over here, you'll see a little simple KML file. Or we can just look at this, you know, this data frame is just a data frame of latitudes and longitudes. So what did we learn? First thing is that when you, I guess a couple things. Let me start just a regular, oh no, yeah, okay. What's the easy way to, Alex, what's the easiest way to show all the dependencies installed on a regular JupyterHub?
Pixi info in the terminal without management.
Pixi info at the.
Yeah, Pixi info or Pixi
Okay.
list. Pixi info.
Yeah, so if I'm here, if I do Pixi list, so we're to manage all the dependencies that we need for OceanHackWeek, we're also using Pixi. And so here's a great long list, right? Wow, there's a bunch of stuff installed in here. If you want to know whether, it's a little bit hard to see, sorry, I'm going to. Chances are everything you want to use is probably installed because we got a lot of stuff in here. And it's an OceanHackWeek. And most of what we use in OceanHackWeek is installed already. But there may be other packages that you want to install, and that's fine. You just have to go through the sort of rigmarole of figuring out how to get Pixi up and running in your local package directory. what is the benefit really, I think, for me is that now I have these different notebooks sitting here in this thing, and I can look at my Pixi lock here, and there's a lot of stuff installed here. Oh, there we go. Sorry. It's not quite as much as the full Pixi list. And so the advantage there is it's a little bit lighter weight to do the install, and every time you remove a dependency that isn't required in your code, it's helpful for other people trying to use it so that they don't have some other version of some package that you didn't even realize was in there that somehow interacts with something else that you have on your dependency tree. So it's just a handy way to keep everything file-based in your directory instead of sort of having to go through the extra step of making sure that your environment is set up with Conda. But really, if you're using Conda already or Mamba already and it's working for you, you should probably just keep that workflow going and get good at it. Pixi just offers some unique capabilities that we're leveraging here. So that's pretty much all I have. And I think it'd be good to stop now and do Q&A. I think I'm a little bit over.
Any questions?
Coming from someone who's used Conda or mini Conda, are there workflows that don't work when switching to Pixi, or like things, traps you'll fall into if you try and treat it the same?
Yeah, I mean, it's like anything, right? Yes, I'm sure. The trap that I fell into is actually you saw on display in this demo, which is it's easy to forget that you have to be explicit about this manifest file in your local directory. You're doing bits, particularly with using the JupyterHub. I do almost all my development just using Jupyter. I use Jupyter for sort of prototyping stuff, and then I move it into Python. Just regular, run at the shell with a cron job or whatever. So in those cases, in one case you have to be a little bit careful to manage it correctly. There is something I didn't talk about, which is Pixi Run. So again, if you're running on your own machine, so instead of creating the environment like Conda, you create your environment, and then you're in the environment, and you can do run code and scripts and all this stuff. In Pixi, if you don't specify that you're running that Python file using Pixi, it won't know to sort of manage the dependencies appropriately. So that is a big change. I put in the notebook, there's a great cheat sheet, which is sort of if you're coming from Conda, how does it work? What's the best to work? It's I thought I had it in there. Hold on a second.
On Pixi.sh.
Yeah, switching from Conda. Yeah, it's at the bottom there for resources. I'll put it in the chat. Yep. Come on. Anyway, so yeah, the people who wrote Pixi are the same people that wrote Mamba. So Mamba is a super fast solver for doing Conda installations, and it's really good. That's what I've been using in my day-to-day until I sort of pioneered this thing for OceanHackWeek. But it was pretty easy to come across, and they're very, they want to make Conda better. It's not like they want to replace Conda. They want to use the same frameworks, the same general ecosystem, but just offer more and better features. Alex, can you talk a little bit about the projects aspect? I don't quite understand how that works.
Yeah, so some of the little hiccups we saw here with Pixi are because we're using it to manage the whole JupyterHub. It needs some really specific setup right now to work that way. But it's designed for really project-focused management, thinking that you have some set of dependencies for a specific GitHub repo is a reasonable way to think about it, that you want shared with all of your collaborators. And Pixi so we went through Pixi add to specifically add those dependencies. There's ways you can say, here are the different types of machines my collaborators may be using, and that when you do that add, it specifically makes sure it can find versions that are compatible for all those machines at the same time, whether it's Mac, Windows, Linux. So for a lot of stuff on the hub, we have Linux and Mac pre-solved if you want to like pull that config locally. You can do, that's one of the big differences from Conda and Mamba, that you have kind of these global named environments. Conda activate, here are my crazy data science hacking tools. Conda activate, I'm messing with buoys. Instead, you go to the repo and Pixi run script or Pixi run JupyterLab. And Christian brushed up against task. You saw that in Pixi.toml. You have named shortcuts that are part of that definition. So Pixi run lab could pop up JupyterLab on a specific port for you with all the packages in that environment. I've used that specifically for tools that I'd otherwise be shipping out, that running in cron scripts or something that in the environment I'm sending it to, I only want a really minimal set of dependencies. But for locally mucking with it, I really want JupyterLab. So it allows you to also create these overlapping environments that if I do Pixi run lab, it gets this much more fully featured environment with JupyterLab and other things, but includes this core set of dependencies that are actually what's going to get shipped out into the field or to some server or to a coworker's laptop who's not going to actually open JupyterLab. So it's a lot of power, a lot of stuff that people have managed really painfully, manually for a while with environment.yaml files or requirements.txt or conda lock, all stuff that we've used the same stuff to manage the JupyterHub in the past, and we've used it to manage environments on our own computers. This team has really, the team behind Pixi has really been the ones that, they were the ones that made Mamba, realized in the process that reinventing Conda wasn't the fix that the community actually needed to work better. So they started up Pixi to build on top of some of that knowledge and seeing how other ecosystems. Python has been managing packages longer than Linux has been public for a scale thing. So there's a lot of history. And
really? I didn't know that. That's
there's been several generations of languages and package managers that have come out since Python that now we're coming back to, and the community's been learning from those, and Pixi is the Conda ecosystem's way of taking those learnings in. Yeah, Python's old.
Yeah. And I've run into that same concept. If you've ever run Red Hat, that Python being old was definitely part of it there. So they're part of their installing of the whole system was based on Python. And if you wanted a different kind of Python, it was a huge pain in the ass, which is, so this file-based, having it really version controlled in your project where it's all right there is super helpful, I think. Anyway, your mileage might vary. Other questions? I know it's a lot to throw at you, and it won't really make sense unless you run into installing a dependency and want to try it. So I'm remote in Seattle, but I will be lurking around on Slack. You can find me there. If you're having trouble, I mean, I don't know the answer, but I can help you troubleshoot to figure out how to get it to work. Happy to do so. So hit me up. I think that's all we got.
Thanks, Chris.